Hello everybody, welcome back. I am the Exam Mastery host, your virtual guide to cybersecurity and the CompTIA CySA Plus journey. Whether you are prepping for the certification or are just curious about defending the digital world, you are in the right place. Every week we break down complex security topics into simple, actionable insights to help you grow as a cybersecurity analyst. Let's build your skills, boost your confidence, and stay ahead of threats together. If you find value here, consider subscribing and sharing your thoughts in the comments. I'd love to hear from you. Hello everybody. Today we're going to be doing SASE, which is basically Secure Access Server Edge Computing, right? That's what I think of it, right? Secure Access Server Edge is what I think whenever I think of SASE, right? So it's Secure Edge Computing. That's how they enable the Secure Edge Computing, right? Combine cloud native and security and networking to protect distributed environments, including edge devices and remote users. So what is an edge device, in my opinion? It's how these technicians would access these internal systems, right? That's what I think whenever I think. That's what I'm thinking right now, right? So I'm telling you my own words what I think it is. It's how these technicians, like remote technicians, stuff like that, even if you were just a person that was trying to remote into a system, that would be Secure Access Server Edge, right? Because you're trying to do a service, so you're needing this edge computing so that you can remote into it, right? Key concepts align with, so we're not going to worry about that. So what is it? A framework integrating networking and security services into a cloud-delivered model. So that's what the SASE is. The edge computing, I believe, is the technician part of it. But it does rely with services, and you'd have to have technicians to be able to do those services and fix those services, right? Zero Trust Network Access verifies every user and device. Firewall as a service, cloud-based traffic filtering. That could be something like pfSense, a virtual firewall, right? Secure Web Gateway. That's just an example of pfSense, right? With Secure Web Gateway, we have protects against web-based threats. Now, what is a web-based threat? Like cross-site scripting, SQL injection, and like API vulnerabilities when you get more in depth, right? Because APIs relate to websites as well, right? And we've been seeing so many like API vulnerabilities coming out, stuff like that. But for Cloud Access Security Broker, we have, what does it do? It secures cloud applications. For software-defined wide area network, we have optimizes the network performance. So what is a software-defined wide area network? Well, you know how AWS has the different regions? Those different regions have sub-regions, right? Where like all this stuff connects to. And that's how we're having low latency across the world. So I could be in Alaska, right? Or I could be in Wisconsin or something. Or like Virginia. And be able to connect to the New York or the Ohio, or wherever they have an AWS place, right? I'll probably be able to connect to it, right? That's just an example. I'm not sure if there's even one in Ohio, but there's probably definitely one in New York, I think, but I don't even know about that. But that's how we're able to connect with low latency, the software-defined networking. Unified security policies, right? So Zscaler, what is ZTNA? What is ZTNA? Zero Trust Network Access is ZTNA, right? Then we have the Secure Access Service Edge platforms, and we see Zscaler as an example. Zscaler policy, and that would probably be for AWS, right? But it doesn't say nothing about AWS on here, so I don't know where you input this command, but Zscaler, Palo Alto, Prisma Access, Cisco, Umbrella, some of the tools. Secure Access Computing, what is it? It's processing data closer to its source with integrated security controls. So I was kind of wrong about that, but it still deals with technicians, right? The Secure Access Service Edge still deals with that, right? But reduces latency by processing data locally, requires security at the edge, encryption and authentication, often integrated with Secure Access Service Edge for centralized management. So what we're doing here is we're just making sure that that data is encrypted on the Service Edge device with AWS IoT, Greengrass, or Azure IoT, or FortiGate. FortiGate's a really good one, but it is expensive, right? AWS is the most expensive out of it, so I'd say AWS is the most expensive thing, right? Because they're just trying to make money, right? Secure Access Service Edge and Secure Edge Computing security process. Nmap is what we would use to identify those edge devices and user access resources. We're seeing Nmap a lot for identification, stuff like that. Implement zero trust policies, enforce identity management, and multi-factor authentication for users and devices. So this is how you would build out your edge device, right? You would make sure MFA is enabled. Whether you're using Okta or just anything, you could be using Ansible to ensure that MFA is enabled. We have secure network traffic and through the firewall as a service and the software. The secure web gateway, my bad. But this is how we block the threats, right? Edge protection, right? Harden the devices with the Ansible playbooks. So what are we doing here? We are IP tables, right? Port 23. We could also do NF tables here, I believe. So you just put whatever command it would be right here, right? And the name of it, and it would do that command, right? Monitoring and log activity with Splunk. We're centralizing logs and detection capabilities in these edge and secure access service edge environments. Access report, we have a little access report. Splunk report for secure access service edge violations. We have all these commands. I'm not going to go over them all, but we still have the TLS thing, right? Best practices for the CySA Plus. Enforce zero trust. Verify all users and devices with multi-factor authentication and zero trust network access. Apply patches and encryption to Internet of Things edge workloads. Use firewall as a service and SWG to block malicious traffic. Monitor continuously. Centralize logs in Splunk or Azure Sentinel for visibility. Use Ansible for consistent edge configurations. And then we just have the compliance factors, making sure we align with our compliance. Challenges in secure access service edge and secure edge computing. Distributed environments securing diverse edge devices and users. Latency concerns, balancing security with performance at the edge level, right? Visibility gaps, integration and scalability. And we have all these commands, right? We have the report. For the CySA Plus exam, just make sure that you know the components that are in a secure access service edge like framework, right? We have the secure access service edge and we have the edge computing devices, right? So we have zero trust network access, firewall as a service, secure web gateway, cloud as a service broker, right? Wait, what is CASP? I'm going to look that up. CASP, cloud access security broker, secures cloud applications, right? So that is just the person, the individual that goes and secures the cloud, right? Devices. So we want to understand those components. We want to know tools like Zscaler, Splunk, Ansible for SASE and edge security. So if you know Ansible, you're going to be a really, really good candidate for these jobs, because if you don't know it, how are you going to actually do it? It's really good on your resume if you know Splunk, Ansible, and secure access service edge, stuff like this. Explain how zero trust and segmentation secure edge environments. Practice configuring secure access service edge policies and monitoring in a lab. So that is going to be it for this video. It's very important that you learn these skills, and we will be doing labs on them after this video. But thank you everybody for watching. If you have any questions, do not hesitate to leave them down below, right? I want to see comments down below because I like hearing from you guys. I like hearing from everybody, right? So thank you for everybody for watching.